Okay, so let's review a difference of squares. So a polynomial in the form of a squared minus b squared is called a difference of squares. And when you recognize a polynomial as a difference of squares, the factoring is easy. I pressed the record button, right? I did. Okay. I hope so. Okay. Anyway, so if you recognize it as a difference of squares, then the factoring is easy. So notice you have a squared. Well, what's the square root of a squared? It's a. You have b squared. What's the square root of b squared? Well, that's b. And notice when you have a minus sign, then one of this is a plus and one of these is a minus. So for example, notice if I were to multiply this out, a plus b times a minus b, you have a times a is a squared, minus ab plus ab minus b squared. Well, this cancels out. So now you're left with your a squared minus b squared, right? So once you recognize it as a difference of squares, the factoring is easy. What do you think happens if we have a squared plus b squared? Can we factor that? No. Unless there might be a greatest common factor in there depending on what a and b is. But this, in general, cannot be factored. Okay? In general, when it's a plus, it cannot be factored. So let's do a few examples to get you rolling. So notice perfect square, right? I can take the square root of x squared. Y squared is a perfect square. I can take the square root of y squared, and it's a minus, so the factoring is easy. Like I just kind of, it becomes, you slap down your x, you slap down your y, one's a plus, one's a minus. What can I say? Okay? Okay, now we have one with a number in it. So, square root of the first term, we can just slap it down. X, square root of the last term, square root of 9 is 3, 3, 3. One's a plus, one's a minus. So they get a little bit more complicated. Notice you can take the square root of 4. So the square root of 4x squared would be 2x, right? 2x, 2x, square root of y squared. Well, that one's pretty good. One's a plus, one's a minus. Okay? If you can recognize this pattern, your life will be so much easier on the test. Let's maybe jump to E. Well, 80 is not a perfect square. If you remember, perfect squares are like 1, 2 squared is 4, 3 squared is 9, 4 squared is... Those are all examples of perfect squares, right? I can easily take the square root of those numbers. No problem. You're okay? Okay, but notice 80 and 45 is not a perfect square. I can't take the square root of 80 and I can't take it of 45. What's the first thing I should do in this case? Yeah. Let's factor out 5. So we have 16a squared minus 9b squared. So notice 16 is a perfect square, 9 is a perfect square, so is a and b. So now this becomes easy. Square root of 16 is 4. Square root of a squared is a. Square root of, I'll put that down in both brackets. Square root of 9b squared is 3b. 3b. One's a plus, one's a minus. So now you know you get nice little complicated issues, but it's still the same. I can take the square root of this, and I can take the square root of that. So it's a difference of squares. So square root of x plus 3 squared is just x plus 3. Square root of 16 is 4. One's a plus, one's a minus. Let's collect the like terms. So it's x plus 7, x minus 1. Okay, when we need to be a little bit careful here, because when we go one's a plus, one's a minus, we're going to have to subtract everything inside there. So let's maybe do this example because it can be tricky. I won't do them all. I don't want to insult your intelligence. So, okay, what do we have here? We go, okay, I can take the square root. I can take the square root. There's a minus sign. Minus means difference. It's a difference of squares, so that's okay. Square root of the first term, square root of the last term. One's a plus and one's a minus, right? So be careful that you subtract everything in this binomial, right? You have to apply that negative sign to the x and to the negative 1. So 2, this will end up with an x, but 2 minus 1 is plus 1, right? And here we're going to have a negative x, and this will be 2, a negative, negative 1. Negative times a negative is a positive, so 2 plus 1 is 3. You could rewrite this if you don't want a dangling negative. You could rewrite it like this. Or another equivalent expression here is if we factored out the negative 1. Let me do that on a scrap piece of paper. You could look at it like this. Factor out the negative 1, and this would equal negative x plus 1, x minus 3. Okay? This is me factoring out the negative x, positive 3. So this is actually a really nice, this is the most proper form. I think it's the most professional way that you can express that as far as mathematics is concerned. Okay, let's do this one. This one has a trick in it. The important thing is to always factor all the way. That's critical, right? You always want to factor all the way. So, square root of the first term is x squared. Square root of the last term is 4. One's a plus, one's... Am I finished? No, this is another difference of squares, so that's sort of what you need to realize. You need to factor all the way. Why don't you take a minute to try k, and we'll go over. Is there anything I can explain better? Anything at all? No? You're good? Just take a moment to try that on your own. So let's take a look at this one. Again, you have a perfect square. In other words, I can take the square root of that. Perfect square, minus sign, difference of squares. So square root of the first term, square root of the last term. One's a plus, one's a minus. So let's just distribute. Here we're going to have x plus x is 2x. Minus 3 plus 3, that's 0. So that's that. Here we're going to have x minus x. Wow, that's 0. Negative 3 minus 3, negative 6. And that equals negative 12x. So you kind of end up with a nice simplified version. Even though we did factor it, that's what we ended up with. For those of you, when you do your work later, I'm going to give you the answers to these so you can check. This would be 3x plus 11y, 3x minus 11y. This one is, take out the greatest common factor. The final answer will be, when you do it on your own, you can check your work. 10 plus 9x, 10 minus 9x. And this one, don't let the fraction scare you. You can still take the square root. So that would be x over 4 plus y over 5 times x over 4 minus. I just want you to have the final answer so that you can check. Okay, now let's do factoring perfect square trinomials. Perfect square trinomials have this form, right? This one is identical to this one, except that has a plus 2ab, this has a minus 2ab. So notice what happens if I have a plus b squared. That's equal to a plus b times a plus b. And notice that we get a squared plus last, I'm just foiling, inner, outer. No, this was first, outer, inner, last. So plus b squared. So notice the pattern, right? So so if I want to factor, if I can recognize this as a perfect trinomial square, then it's easy to factor, right? I just follow that pattern. Notice 2 times the square root of the first term times the square root of the last term equals 2ab equals the middle term. That's the rule you use to determine whether or not something is a perfect trinomial square. To determine whether a trinomial perfect square, whether a trinomial is a perfect trinomial square, check that the middle term equals 2 times the first term times the last term. Okay? If you can recognize these as a perfect trinomial square, the factoring is easy. So let's just give this a check. Okay? Let's see if this, to check to see if this is a perfect trinomial square, you go 2 times the square root of the first term times the square root of the last term equals 2 times m times 7 equals 14m. Do not worry about the sign. In the context of this checking, we don't have to worry about getting a negative. Notice it is a perfect trinomial square, so now the factoring is easy. Square root of the first term, square root of the last term. Since that's a minus, both of these are a minus. Can I explain anything better? Yes. For this, no, there's usually no marks allocated for that. Yeah, but know this formula because there's usually some trick questions or sometimes TI questions or regular questions that involve this formula. Okay? Yeah. All right. Let's look at this one. Let's just notice it's a perfect square, a perfect square. So let's check to see if it's a perfect square, perfect trinomial square. Let's just check, okay? We go 2 times the square root of the first term times the square root of the last term, and that equals 5x times 1 is 10x. Oh, not a perfect trinomial square. Not a perfect square trinomial, okay? Because of this. It's not a perfect square trinomial because of that. Can we factor this? I don't think so. I don't think we'd ever come up. Let's see. 5x, 5x. The only way to factor this last term is plus 1 plus. No, I don't think so. Huh? Yeah. I'm just trying to see if I can factor this the regular way, but I don't think so. Even if I try 25x times x, there's no way I'm going to come up with that middle term. This cannot be factored over the integers. Let's try this guy. 2 times the square root of 4x squared times the square root of 25 equals 2x times 5 equals 20x. Notice I got the middle term, right? As soon as I see it, oh, I can take the square root of that and I can take the square root of that, I would check because that saves you a lot of work, right? Check to see if it's a perfect trinomial square. Yes, it is. It is a perfect square trinomial. So 2x, square root of the last term, right? So this is just equal to 2x plus 5 squared. Anything I can go over? Anything at all? I'm going to give you the answers to these just so you can try them on your own. Now let's do this one together because notice we have a perfect trinomial square. So we have a perfect square here, a perfect square here, and a minus sign. So first we need to factor this. Let's check. 2 times the square root of x squared times the square root of 9 is 2x times 3. That equals 6x. I get the middle term. Again, don't worry about the minus sign in this context. So right away you know this is x minus 3 squared minus w squared. Right away you know that. Okay, now we have a difference of squares. And we're done. That's our final answer. Before we leave this page, is there anything I can explain better? Any other questions? Let's go. Determine the value of k such that each trinomial is a perfect square. Oh my. Determine the value of k such that each trinomial is a perfect square. Let's see what we can do here. Well, let's see. We know that 2 times the square root of 9x squared times the square root of 25 has to equal kx. So, we're going to solve for this to find this. So this is going to be 2 times 3x times 5 equals kx. So we have 6 times 5, 30x equals kx. So divide both sides by x, k equals 30. Good? This is why I really want you to know that pattern, because this is a common type of test question. Right? Oh, let's look at this guy. 2 times the square root of 4x squared times the square root of k has to equal 12x. In this context, we're not going to worry about the sign. Okay, so 2 times 2x root k equals 12x. 4x root k equals 12x. Root k, well, 12x divided by 4x is 3. How do I solve for k? What do I have to do to solve for k? We're going to square both sides, so k equals 9. Let's try one more. 2 times the square root of the first term times the square root of the last term has to equal 40xy. We don't, again, in this context, we're not worried about that minus sign. So, I can take the square root of x squared, so I'm just going to take the square root of x squared, but that k stays in there. Square root of this is 4y equals 40xy. So 2 times 4 is 8xy root k equals 40xy. 40xy divided by 8xy is root k like x divide both sides by x, divide both sides by y. 40 divided by 8 is 5, so k equals 25. Sorry, if you can't see the page, just call me on it, okay, and I'll correct it right away. Because I don't always look at the screen, so. Okay, the last item we're going to talk about is factoring by grouping. All right, let's see what we can do here. Well, fact, basically we want to get two terms where we can get the greatest common factor. This has nothing in common, but if we rearrange them a little bit, they do. Ax plus xb minus by minus ya. See how I'm just arranging them? Now I can factor out an x. Here I can factor out a negative y. So x times a plus b minus y times b plus a. This is a plus b, b plus a is the same thing, right? So we have a plus b, x minus y. Let's try to arrange these guys a little bit. Well, these don't have anything in common. These don't have anything in common. Oh, they have a 3 in common, but these two don't. So maybe we can just stick the 3a with the well, let's see. Why don't we stick AB with the B and 9 with the 3a? So we have 9 plus 3a plus AB plus 3. Sometimes you just have to play around with it a little bit. So this, take out the greatest common factor of the first two, plus b 3 plus a plus 3, same thing. A has a positive sign, 3 has, we're just fine there. So this is going to be a plus 3 times b plus. And I just switched it around a bit, but it's the same thing. Well, I rearrange. Let's try working with these two and with these two, see what we get. Perhaps it's okay the way it is. In my solutions I did rearrange it. Let's see what we can get. What would be the greatest common factor here? Huh? 2x, right? So that would be, we're just going to do the first two, right? See how we're factoring by grouping? We're going to group these two together, group these two together. So this is going to be 2x plus 3y plus 4 times 3y plus 2x. Oh, okay, that works out. That's the same. So we have 2x plus 3y when I factor out the greatest common factor out of these two terms, and that's 2x plus 4. Am I done? Is this a complete answer? Do you see a greatest common factor here? So let's factor out the 2. Right? Now I'm done. I'm just going to do one more because I'm worried I'm in insult. But the answer to this one is 4ab minus 3c. You can try that on your own. b minus 3a. This one is a minus c x minus y. And this one we'll do together. We're going to factor by grouping. In this case, whenever you see something like this with a minus there, just consider it, if maybe we can rearrange this so it's a difference of squared. So this is going to be a squared plus 2a plus 1. This is a perfect trinomial square minus p squared. Okay, so that's what you want to watch out for. 2 times the square root of a squared times the square root of 1 equals 2a. That's the middle term. So now we have a plus 1 squared minus p squared, perfect square trinomial. So now it's easy to factor, right? Okay. Just watch out for these tricky guys. Anything I can explain better? Okay. I'm just going to walk around and see if you have any questions, and I'll stop recording it right